perform task 2, you will need a series of components. The user guide that you've been provided will be useful in order to remind you of everything that I will go over to you in this video. There's a diagram in that user guide which will show you which components are necessary, and within the user guide you will see a breakdown of what components connect to which components and what each of their functions should be. To begin with task 2, you will need to actually import the dataset into the workspace. In order to do this, first you use the dataset importer tool. This tool will allow you to scan the machine in order to find what datasets are available to you. In the case of this evaluation, you will only have a single dataset available to you. In order to choose which dataset you will use the dataset selector, which, as mentioned, there will only be one available to you. On the demo machine that I am showing you here, there are multiple datasets, and I will go ahead and choose a Baseball Hall of Fame dataset in order to demonstrate the functionality of the system today. Once you've selected the dataset that you will be working with, and even though there is a single dataset, you will still have to go in and select the option and select the specific dataset that you will use. For task 2, you will use the default problem generator in order to import the provided problem that you will be working on into this particular workspace. And once you've connected each of those components, you run each one independently. And once you've run these 3 components, you will now have access to the dataset that you should be working with, as well as the problem that you've been asked to work on for this particular task. The next step of the task will be for you to actually do a model search in order to identify a number of candidate models that may be able to solve the provided problem for you. Here you can connect the dataset and the problem into the model search. And while it's running, you will be able to see that the icon on the bottom left will actually show that it is running, and when it's complete, this will turn green and it will say that it is complete. For now, you will actually have to wait for this to finish running before you can continue with this process. So upon completing the model search, what you can do is you can actually compare these different models by using the model score component. The model score component will allow you to, in this case I'll show you with 2 different ones, the model score component will allow you to compare the set of models that is returned from the model search along a number of different performance metrics. And there's a range of these. For instance, the accuracy that those models are able to predict their desired output that you want. There's a number of other metrics here too, depending on your familiarity with various statistical and machine learning measures. You'll be able to choose from a range of metrics here as to how to compare the performance of these models. And I will repeat this for both of these model sets. In this case, I know that this is a classification problem where I'm trying to classify whether or not certain baseball players are in the Hall of Fame. So I will go ahead and use F1 and accuracy as my 2 metrics. And then from here, I should be able to run both of these components. And as mentioned before, while it's running, the bottom will state that it's running. And during this time, while this is running, if you attempt to actually make any modifications to space by adding additional components, you will get a warning that the workflow cannot be modified. So while we're waiting, you will have to wait for the system to actually complete scoring both of these. And once the system has completed scoring of all of your models along any of the metrics that you've requested, you can go ahead and actually compare the performance of each of those models using the visualization component for compare model scores. This component will generate a bar graph that shows the score along each metric that you've chosen and will allow you to compare the models. Once it is completed scoring each of these models, you can drag the compare model scores component in, and you'll have to drag one for each time that you've generated a different set of model scores so that you can visualize each of these separately. And again, you run the workflow, and it is recommended that if you want to compare the models along two or more different metrics, that you actually use separate model score components in order to do this, as opposed to using the same model score component and changing the options. What this will allow you to do is once you've scored it along one metric, you're able to quickly compare the scores of each of those models across the different metrics without having to rerun the score component. So once the compare model scores component is completed running, you can actually view the visualization by clicking on the magnifying glass on the right-hand side. When you click on that, it'll open up a new tab in your browser, and within that tab, you'll be able to view the bar graph that I mentioned. This bar graph shows the accuracy, in this case, of each of these models that was returned, of these 17 models that were returned. And when you hover over any of these models, you can see the score along the metric that you've chosen. So in this case, we can see here that model 4 9373. So we can see that model 1 would be our best performing model. Model 4 appears to be model 13 appears to be our next best performing model. And so if we make note that our accuracy is, we get model 1 and model 13. Now, once you've completed comparing the model scores, and you believe that you've determined which models that you believe are the top 1 and 2 ranked models, according to the number of metrics that you believe are important to you from your particular domain, you will want to actually rank these models. In order to produce a set of ranked models, you will actually have to first fit the models using the model fit component. The model fit component, which I will show you in a moment, it takes as an input both a data set as well as the output of the model search. So the model set that the model search outputs. The result of the model fit component is a set of models that can actually be used to make predictions on data. So here, once you've fitted the data to the models, you will now have a fitted model set. This fitted model set is what will be necessary to produce the rankings. Now the ranking module is very similar to the scoring module, except in addition to specifying what metric you want to use to compare models, you also need to specify the rank order of whether along that metric, whether a higher value is a higher rank or a lower value is a higher rank. In this case, accuracy. The higher the accuracy, the better performing the model. Now, typically, the way this component would work is that would be the end of this. However, due to a bug in the system at the moment, regardless of which rank sort order that you choose here, all models will be sorted according to lowest is better. In other words, regardless of whether I choose an accuracy metric or a mean square error metric, the lowest value along that metric will always be ranked as first, and the highest value will always be ranked as last. Unfortunately, that is a bug that is in the system now, which could not be fixed before the evaluation. And so, after following this, you will need to actually use the model re-rank component in order to re-rank the model that you have selected as the best model and place it at the top of the ranked list. Now, I've gone and selected the model fit and also the ranked models components. And here, I'll go ahead and run both of these components. And once these components are complete, I can use the model re-rank component in order to re-rank the model that I believe is best. According to the scores that we have reviewed so far, according to accuracy, Model 2 appears to be the best model. And so in this case, I would go in and manually re-rank Model 2 as the #1 ranked model in this model rank set. Now, once you've completed ranking the models in this way, and after you've completed reordering the rankings such that the model that you believe is the best performing model has been re-ranked to be the top ranked model, you should then use the model export component in order to export that list of ranked models. And once you've run the model export component, your work on task 2 will be done. And then from there, in order to complete the task, you can simply close out of the browser. So here, once it has generated the set of fitted models, it is now ranking those models according to what I've selected as the accuracy metric. It will be erroneously using them as the lowest accuracy as the top ranked model. So I want to ensure that I re-rank those models after this is done running, such that Model 2 will be placed at the top rank. So here, I will go into the options, and I will select Model 2, which is here. You can see the model number as the number after the dash. And then I will want it at rank #1. And as mentioned, once you've completed the re-ranking process, you can continue this for as many models as you feel you would like to add, but we specifically request that you at least re-rank the top ranked model. In order to complete this task, you simply use model export. There are no options for this particular component. You can run this, and once this is finished running, you will be able to complete task 2 by simply closing out of your browser. And with that, that is the end of the tutorial for completing task 2 using the Tigris workflow tool from Carnegie Mellon.